This video is brought to you by Michael Speaker and Maximilian Willard from Solis Willard. In this video we will show you important changes in the code generation of Rhapsody for interfaces using the RXF framework version 8 for C. Before we start, we would like to briefly discuss when interfaces should be used and what their advantages are. Interfaces should always be used when individual model elements are to be structurally separated from each other. This means, for example, that two classes should communicate with each other via operation calls or events without having any insight into the structural design of the other class. Particularly in the programming language C, in which a class is represented as structure, there are no predicates such as protected or private to prevent access from class-to-class variables, keyword information hiding. An interface defines therefore a communication between two classes. By encapsulation of individual model elements through interfaces, each model element remains independent for itself, since there is no direct relationship to other model elements. This modularity offers the following advantages. Individual model elements can be easily exchanged or reused in other projects, and the testing of model elements becomes easier, since there are no directly linked model elements that must be stubbed. In the following, the differences of the conventional code generation for interfaces, marked as OXF, compared to the new code generation, marked as RXF, will be shown. First, we will discuss interfaces with operations only, without event receptions. Let's look at the specification of an interface. In the conventional variant, you can see that in addition to the entries in the virtual table, there is an offset attribute. This is needed when calling an interface operation. With the offset, the address of the to-be-realized object can be calculated in the interface operation, together with the transmitted interface pointer. More about this later. In the new variant, no offset is needed anymore. Instead, the class to be implemented stores the object address in the variable realme, which is located in the interface next to the virtual table, when an object is initialized. With the conventional variant, OXF, one sees that the offset is initialized as part of the virtual table. The operation offsetOff from the library stddef.h is called. It should be noted that this operation is not MISRA compliant. The finished initialized virtual table is then given to the init operation to store it there in the interface object. The new variant of the interfaces functions without an init operation of the interface. The me pointer of the object to be realized is made known to the interface object as part of the realizing class in the initialization of the realizing class as well as the virtual table. Thus, the initialization of an interface can be accomplished faster, since on the one hand no offset computation must be accomplished, and no call of the init operation of the interface which can be realized must be accomplished. When implementing an interface operation with conventional code generation, it now becomes apparent that the address of the object to be implemented must still be calculated. The computation of pointers at runtime can represent a source of error under circumstances and is furthermore not MISRA compliant and should therefore be avoided. With the new implementation of interfaces, the realme pointer stored in the interface can be used directly as call parameter for the operation which can be realized without still computing this. This results in two advantages. The call of an interface operation takes place faster, since no computational steps are needed, and it can be done without pointer computations. Furthermore, there are new features for interface operations. With the property interface default return value, it can be set which value should be returned if an association to an interface should not be initialized. Thus, one can prevent that an undefined value is returned, since in some cases the variable res is not initialized correctly. Also, one can switch off the null pointer checks using the property interface use null pointer check, so that without examination the realizing operation is called to realize a faster operation call. Thus, one would have then a comparable behavior to other languages like C++ or Java, in which also no null pointer checks are accomplished. This property is switched on by default and should be switched off only with a static linking of objects, with which one can go certainly that on the one hand the association is initialized on an interface and that also the respective operation is implemented by the realizing class. A further advantage of the new interface generation is that now also singletons can realize interfaces correctly. On the one hand, no more unnecessary wrapper operations are generated, which do not realize an interface operation. Last but not least, there now is a correct implementation of triggered operations, which can be called over the interface. Now let's look at the interfaces with the event receptions. In this example, an interface with event receptions only is presented without operations. This is for a simplified demonstration. Operations and event receptions can of course be used together in an interface. Let us first go back to the specification. With the conventional variant, a further generic interface class, RXF reactive, is needed by the RXF. From this class there is now a part in the interface class next to a pointer to a virtual table. This object of type RXF reactive is used as a generic entry point to send events to an interface, but more about this later. In the new implementation, a virtual table can be omitted for purely reactive interfaces. The interface contains only a pointer to the RXF reactive structure. When initializing an interface of the conventional variant, the RXF reactive object must be initialized with a virtual table that has a function pointer that points to a gen operation of the interface. In the realizing class, a virtual table is now created for the interface to be realized, which has a function pointer that points to a gen operation of the realizing class. With the new variant, it is sufficient that with the class to be realized, the RXF reactive pointer of the interface object is initialized with the address of the reactive object of the realizing reactive class. The implementation of the gen operation for the conventional method is then comparable to an operation call via an interface. Here likewise, a pointer computation is accomplished for the pointer on the realizing object under the utilization of the interface object address and the offset. In the gen operation of the realization, the final framework operation RXF reactive gen is called, which then puts the final event into the associated message queue. The whole thing becomes clear if one records the individual calls of the individual gen operations in a sequence diagram. In the conventional variant, 3 additional operations had to be called when sending an event via an interface, 2 of which are indirect calls. In the new variant, on the other hand, virtual tables can be left out completely, and a direct call to the framework function can be made, which then places the event in the corresponding message queue. Finally, it is still to be mentioned that both presented variants, the conventional, just like the new, possess outward the same interface. This means that Rhapsody models that use interfaces can be used with the RXF as well as with the RXF. We hope that we could create a higher acceptance for interfaces for you with this video, so that you can use them more consciously in your models. Thank you for watching, and feel free to check out the other videos on our channel.